Okay, halogenation, the addition of the halogen to the alkene compound. As we agreed before that, I will continue explanation. If you have any misunderstanding or any question, please ask me. Halogenation here is the addition of the halogen X2, okay? A chlor or a brom, not the fluor, not the iode, because the fluor is so active and the iodine is the reaction of iodine is very, very slow reaction. Okay. Now, the chlor or brom to an alkene, okay, forming vicinal dihalide. Dihalide, that meaning you have two halogen near from each other. That meaning that both of the halogen atoms on the neighboring carbons. Okay? Both of the halogen atom on the neighboring carbon, we say vicinal dihalide. Now, here you have X2, that meaning the pi bond will be open and the X2, one of the halogen will be come to here and the other halogen atom, it will be bound to this carbon. Now the halogen, the synthesis of the halogen is useful. Look, with the chlor, with Cl2 or Br2. The dichloride and dibromide formed in this reaction here, look, with the starting material of the alkene. That meaning if you have alkene double bond, directly added, if you have the halogen directly added to the double bond, and it will be give you the product. And here there is no Markovnikov rule because both of them is the identical atoms. Okay, no problem if the chlor here and the second chlor here or reverse. There is no Markovnikov rule. Just put it on the double bond and it will be give you the product. Now he said here the halogen added to pi bond because halogens are polarizable. Okay, he said halogens are polarizable. What meaning halogen are polarizable? That meaning if you have X2 like this, I will make for you sharing with the paint. Okay, here it is. Okay, like this. That meaning if you have halogen here, okay, for example this iodine, okay, iodine, okay, and we know the halogen is high electronegativity. That means both of them is equal. You will say to me the total charge for this molecule it will be zero, and this this molecule nonpolar. Okay, yes, you are right. This this molecule nonpolar. But if this molecule come near from something reach electronegativity, like the double bond, for example, like this, come to near from this carbon, double bond carbon. Okay, now this is high, this is reach electronegativity atom. That meaning we have negative charge here. Okay, we have negative charge here. For sometimes the halogen it will be polarizable. That meaning for just a few seconds the halogen it will be partially positive, partially negative. When it will become near from something high electronegativity or reach electronegativity, or there's electrons with negative charge, we know that. That means with short times it will be partially positive and partially negative. That meaning polarizable. Polarizable, that meaning can be, there is the dipole for the molecule just for short time when it will be meet with something reach electronegativity, reach with the electron density. Here the meaning of the polarizable, okay? Don't Confused with the halogen. Yes, the halogen nonpolar compounds and nonpolar molecular and equal to 0. Yes, but polarizable can be able to make dipole for just a few seconds when they meeting with something electron rich like the double bond here. Okay. Look, he said the electron reach a double bond induce the dipole. Look, induce يعني تحث. Okay, حث the dipole to the halogen at the molecule to be partially positive, partially negative. Okay, and the electrophile halogen atoms then attract to the nucleophile. Look, the electrophilic halogen atom, it will be attracted to the nucleophile. That meaning the nucleophile, that double bond, it will be attack the partially positive sides of the molecules, and the addition it will be happened. Oh, what is the mechanism for this addition? Here the mechanism for this addition. Step number 1, addition of the electrophile X to the pi bond. That meaning here the pi bond, it will be attack the partially positive end, and then this it will be make for us it is like intermediate. We said a bridge halonium ion. Okay, halonium ion. We have positive charge where on the halogen. If you have positive on the carbon, it will be carbonium ion. If you have positive on the halogen, it will be halonium ion. Okay. Here, don't forget this the intermediate. This the intermediate, and the carbocation are not intermediate in the halogen. Yes, and don't say we have carbocation here. Okay, there is no carbocation in this mechanism. Okay, there is no carbocation. Now, step 2, look to the step 2 is easy. The negative part of the halogen, it will be attack, it will be work as nucleophile, and it will be attack the carbon, and this bond here, this or this, it will be open. It will be open to add both the electron to the halogen atom, and the addition, it will be finally happened like that. Okay, that means just 2 steps. Step number 1, the polarizability of the halogen make the halogen partial positive, partial negative, and the double bond of the alkene, it will be attack the halogen to make for you a bridge intermediate of the halonium ion, and then this the negative charge, it will be attack the carbon here or here to give you the final addition of the alkene compound. Do you understand? Do you have a question here about the addition of the halogen or the mechanism? Okay, now we will go to the next reaction, is the halohydrin formation. No, the halohydrin formation. Okay, that meaning we have, look, the halohydrin meaning on the same molecule we have 2 functional group, the hydroxyl group and the halogen group. Okay, we said halohydrin, the halogen and the hydroxyl. Now, a treatment of the alkene with the halogen and the H2O, yani both of them, the halogen with the H2O, okay? It will be from what? It will be from halohydrin by addition of the elements X, the halogen of the hydroxyl, to the double bond, okay? And here, look, we have be careful about this reaction. If you see we have the halogen with the H2O molecule, that meaning the addition will be happened to here. Okay. Then look to this reaction. You have the ethene and you have the halogen and the H2O in this reaction. Directly it will be give you the halohydrogen. Okay, it will be give you the chlorohydrogen. That meaning one of the halogen atom, it will be added to the carbon, and the second hydroxyl group, it will be addition to the next carbon for the double bond. Oh, now the mechanism of this reaction of the halohydrogen formation, look, he said is similar to the mechanism for the halogenation. That meaning in the same time, for the first step, we have the same intermediate is the halonium bridge here. Okay, here, remember that. Okay, now and look, he said the addition of the electrophile X from the halogen to form the rich halogen ion, followed by the nucleophilic attack by the H2O from the back side on the 3 membrane ring. Okay. Oh yes, the nucleophile will become from the back side as the first mechanism. Even though the halogen, it will be the minus, yes, it will be formed, but it will be don't add it or don't attack from the backside, just because the H2O is ready, and in the mixture of reaction, it will be directly attack the carbon of the bridge halogen ion. Here, the meaning here. Okay, I explain for you this all the mechanism. Now, look to the first step, the addition of the X and OH halohydrogen formation. Now, take the halogen. We said we polarizable the halogen molecule, and here it will be attack and give you the bridge intermediate. Okay, this first step is easy, no problem. Now, the next step, nucleophilic attack of the H2O and lost the proton. Okay, that meaning we have H2O already inside the reaction. It will be directly attack the carbon here. And why? Because this carbon is partially positive. Also, this carbon is partially positive. That meaning the H2O, it will be attack the carbon, and this it will be open. Okay, to give you this intermediate, and then the H2O group plus here, it will be loss of proton to equal this positive charge, to remove this positive charge, and finally give you the final product. Okay, that meaning nucleophile attack of the H2O open the halogen ion ring, okay, forming a new carbon-oxygen bond. And this is the next step, directly loss of proton to form neutral halohydrogen, okay, because we know all the compound with positive or negative charge, it will be not stable. And he said here, look, with asymmetrical alkene, that this, like this alkene, this symmetrical or no, if make this 2 part, okay, now this part it will be like, or this side to be like this side, no, we have different here. Okay, this now asymmetrical alkene, that meaning we have 2 constituents are possible to form, okay? That meaning this, you said for yourself, the brom it will become to here and the OH here, or reverse, the OH here and BR here. Okay, now anyone it will be the major one, or anyone it will be forum, or anyone it will be not forum actually. And he said 2 constitutional isomers are possible from the addition of the X and OH group, but only one is formed. Okay, anyone this, look, anyone this. Okay, if you think about this, that meaning the BR come to this carbon, That means the Br added to this carbon. This carbon more hydrogen atom. That means carbon less substituted. Okay, that meaning the positive part of the halogen, it will be added on the on the carbon on the less substituted carbon. Yeah, that meaning it is like Markovnikov, طلبة. Okay, it is exactly like Markovnikov. The positive part, it will be added to the less substituted carbon, or the carbon with more hydrogen. Okay, or the carbon with more hydrogen. And then the OH minus, the negative part, it will be added to the second carbon. Okay. The preferred product has the electrophile here, X, bond to the less substituted carbon atom. Okay, less substituted carbon atom. That means it is like Markovnikov rule. Okay, and here the H2O, the nucleophile, it will be bound to the more substituted carbon. Okay, that meaning be careful about this. This also important note. And be careful about that. This, it is like Markovnikov rule. Okay, exactly like Markovnikov rule. The positive part, it will be added to the less substituted carbon. Here, the electrophile, or the positive part, it will be added to the less substituted alkene. And the halohydrin mechanism, the mechanism involves 3 steps. The right determinant step, it is not important for you. There is no rearrangement can occur. Why? Because there is no carbocation. There is no carbonium ion, طلبة. For this reason, there is no rearrangement. The electrophile, look, the electrophile X plus bond to the, it will be bond to the less substituted carbon. يعني like Markovnikov rule. Okay, I hope you understand this. If you have a question, طلبة, just ask me, okay? I will close this. Okay, now, the next reaction is the hydroboration oxidation, okay? Is the hydroboration oxidation. He said here the hydroboration oxidation is 2-step reaction. Look, the first step, it will be hydroboration, and the next step, it will be oxidation. That meaning 2 reaction. Okay, طلبة, 2 reaction. The first reaction, it will be hydroboration. The second reaction, it will be oxidation. That meaning 2-step reaction sequence that convert alkene to an alcohol. Okay, that meaning it will be like any reaction. Any reaction give you from the alkene give you alcohol. The first one, the hydration, it is like hydration. Okay, from the alkene give you alcohol. Okay, that meaning also the same functional group for the product. From the alkene give you alcohol. Also here from the alkene, look, from the alkene give you alcohol. If you go back to the first reaction, the hydration, the same thing. You have alkene, addition of the H2O molecule with the acid as a catalyst, give you alcohol. Okay, the same thing here. Okay, where is the different? We will see where is the different here. Okay, why this reaction is important for sometimes. Okay, now here we have alkene. Look, the hydroboration, the first reaction is the addition of BH3. Okay, that meaning BH3, it is like acid, طلبة, it is like acid, give you proton. That meaning the double bond, it will be take a proton. And the second part, it will be added to the next carbon. That meaning we add hydrogen here and BH2 here. Okay, the hydrogen, BH2. Alkyl boron. Alkyl boron. Okay, compound. Alkyl boron. This is the طلبة, this is the boron functional group here. Now, the second step is the oxidation. Okay, is the oxidation. Now, convert the BH2 to the OH. Just the BH2 oxidation to the OH by using peroxide, hydrogen peroxide with the base. Okay, hydrogen peroxide with the base. This. Okay, now also he give you here the hydrogenation is the addition of the boron BH3 to an alkene, forming alkyl boron. Oxidation convert the carbon the carbon B here the carbon the carbon here this bond, okay, focus on this bond to the what, to the carbon oxygen, this the carbon oxygen, okay, that meaning convert the BH2 to the OH, just like that. Okay. Now take this ethene BH3, like this symmetrical, yes, okay, no problem, this symmetrical alkene. That meaning if you put the hydrogen here, the BH2 here, no problem. If you added the hydrogen here, reverse, okay, and there is no difference. Now, give you this compound, alkyl boron, okay? This is the compound. Now, oxidation, that meaning this group here, this group, it will be converted to the OH, to the hydroxyl group, to the alcohol, give you alcohol. Hydroxylation, oxidation, two-step reaction. Okay, this, okay, this compound, cyclohexene, BH3, give you BH2, hydrogen. Okay, now oxidation, BH2, it will be give you OH. Now this is the product. Okay, and also look to this. This symmetrical alkene or no? Yes, it is symmetrical alkene. Now we will take just the first number one, the hydroboration. Okay, how the BH3 group it will be added to the double bond? Are there is any special condition? Are there is any rule? Yes, we have rule here. How the BH3 it will be added to the double bond. The first step in the hydroboration oxidation is the addition of the element of the hydrogen BH2 to the pi bond of the alkene, forming what? Forming intermediate hollow, intermediate alkyl boron. This is the intermediate, okay, intermediate product. Okay, and he said here, he explained about this addition because the syn addition, طلب syn addition, this type of the addition we have that meaning the BH3 it will be come from the first for the same side of the double bond. We said syn addition of the double bond occur and no carbocation rearrangement and absorbed. There is no carbocation. Okay, carbocation are not formed during hydroboration. Okay, like this. Look, if you look to this, there is no carbocation. Okay. Here the proposed mechanism involves the concerted addition of the edge BH2 from the same, look, this, from the same side of the planar of the double bond. Here the same side of the planar of the double bond, meaning syn addition. They say syn addition. طبعا this related with the stereochemistry, الكيمياء الفراغية. Okay, but here for understanding how the BH3 it will be added to the double bond because it's so important for the next step. Okay, that meaning the BH, look to the BH3 it will be come from the same side of the double bond. Okay, from the same side of the double bond. Okay, for the planar of the double bond, yes, the pi bond of the and the edge here the hydrogen are broken. Look, that meaning this pi bond here it will be added, and this it will be BH bond it will be broken to add it to this carbon and give you this transition step. This transition step like this. Okay, like this. To give you a new sigma bond R formula. That means we have a new sigma bond here and we have a new sigma bond here. Okay, that means this pi it will be broken and this sigma bond it will be broken, and we have two sigma new bond here. Okay, And because four atoms are involved, look, we have here 1, 2, 3, 4, 4 atoms. Okay. Here the transition step. Focus on this. Okay. Now, this is the intermediate. Now, the second step, this it will be broken, and this it will be broken to give you the syn addition, the HBH2. Okay. This is the first step. And here to the next step, the hydroboration is regoselective. What meaning regoselective? Regoselective, that meaning it is like the hydration of the alkene, give you just one product. Okay, the hydration of the alkene give you one product according to the Markovnikov rule. Okay, that meaning is regoselective. Regoselectivity, يعني there is a selectivity for the reaction. Okay, that meaning on the paper, if you think for this reaction, you will be said for yourself, I will be have two products, this and this. Why? Because this asymmetrical alkene, and I will add the hydrogen here, BH2 here, give you this product. Or reverse, I will add the hydrogen here, BH2 here, it will be give you this product. This on the paper, okay. But in the fact, when you work in the lab, you will be see the different. You will be see just this compound. There is no this compound. Okay. For this reason, we say regoselective. Okay, regoselective meaning the reaction give you one product if there is any probability to the another products. Okay, this is the regoselectivity. Okay. Anytime it will be happen for the unsymmetrical alkene. Okay, for the unsymmetrical alkene. For the symmetrical alkene, no problem. Okay, no different. But for unsymmetrical alkene, no. We have rule how the molecule to be added on the pi bond, on the double bond. Okay, and he said with unsymmetrical alkenes, the boron atom bond to the less, look, to the less substituted carbon atom. Okay, that meaning the BH2 here, the BH2, it will be bond to the less substituted carbon atom. That meaning with the carbon with more hydrogen atoms. Okay, now we have BH3 here. The hydrogen, look, the hydrogen it will be come to here, and the BH2 here. Okay, طلب عكس ماركونيكوف بالضبط. Okay, it is exactly reverse to the Markovnikov rule. On the Markovnikov rule, if you remember, the hydrogen, it will be bond to the carbon, to the less substituted carbon, or the carbon with more hydrogen. No, here reverse, exactly reverse. The hydrogen, it will be bond with the carbon with more substituted, okay? Or with the carbon with less hydrogen. And the BH2, it will be bond to the carbon, less substituted carbon, this. Okay, remember, the boron atom, this is so important, طلبة. The boron atom bonds to the less substituted carbon atom. Okay, عكس reverse to the Markovnikov rule. Now, if you remember, if you look, you have this addition. Okay, now we have BH3. That meaning the hydrogen atom, it will be come to here or to here. According to this rule, no, it will be bond to here. Okay, bond to the carbon with more substituted. And the BH2, it will be bond to here. Okay, why? Some of you will say, why the BH2, it will be bond to here, not it will be bond to the more substituted alkene? Because the stability of the transition state, طلبة. Okay, the stability of the transition state. Okay, look to here. If we make for this reaction, the BH3, it will be bond like this to give you this transition state, okay? Or reverse, عكس طلبة. The BH3, the hydrogen come to here and the BH2 here give you this transition state. Anyone is more stable, okay? This, to the up transition, it will be more stable. Why? Because the positive charge, it will be happen for the positive charge carbon, it will be more stable. Why? Because the CH3, the alkyl group, donating electron for this partially positive carbon and make this carbon more stable. Okay, make this carbon more stable. That meaning the CH3 group stabilize the partial positive charge. Yes, but here if you make like this, here the positive charge, there is no alkyl group here. Okay, that meaning this transition step, it will be less stable. Anyone is best, this is the first one, the more stable transition state, and give you the product. This is the product. Okay, بالعكس reverse, no, there is no this product, there is no this product. Okay, and hydroboration, the boron atom. Look, the boron atom bond to the less substitute carbon. This so important, طلبة. Remember this. This so important. Okay. Why? Because there is reverse to the Markovnikov rule. عكس Markovnikov rule. قاعدة Markovnikov. Now, what alkyl boron is formed from the hydroboration of each alkene. Now, you have this alkene. Symmetrical? No, not symmetrical. That meaning the BH2, it will become to here or to here? That meaning the BH2, it will become to here, to the less substituted carbon. This is the less substituted carbon. Or the carbon with more the hydrogen. Okay? And this symmetrical or no? Also not symmetrical. That meaning the BH2, it will be here or to here? No, it will become to here. Okay? This symmetrical alkene? No, also not symmetrical. That meaning the BH2, it will become to here. Okay? The BH2, it will become to here. And you write the product in your home. Okay? This homework for you. Write the product for this three combo. Easy, so easy. No, nothing difficult, actually. That meaning this addition is reversed to the Markovnikov norm. And the second one is the oxidation. Okay, oxidation, there is no something here. Just convert the BH2 to the OH. Okay, the BH2 to the OH. Just with what? With hydrogen peroxide and base, OH minus. Okay. What is the mechanism for this reaction? Okay, no, not important for you because we have oxidation and electron loss, electron. Okay, this mechanism is not important for you now. Okay, just I want to know the oxidation. Just replace the carbon boron atom with what? To the carbon oxygen bond. خلاص. Forming what? Forming hydroxyl group. يعني كحول, give you كحول. Okay. Just like this. And here. Okay. Now, look, the hydroboration, oxidation of the alkene. The mechanism, the addition of the hydrogen BH2 occur in one step. Yes. No rearrangement. Why no rearrangement? Because there is no carbocation, طلبة. Okay, carbocation نينا. Rearrangement هنا. Carbocation هيا, rearrangement هيا. Okay. Rego selectivity, yes. The OH group bond to less substituted carbon. Look, the OH group bond to less substituted carbon. Okay, يعني عكس ماركونيكوف طول. عكس تفاعل عوية طلبة. The first reaction, the hydration, it is exactly reverse to the hydration reaction. Okay, because in the hydration reaction, the OH, it will be this. The OH, it will be bond to the more substituted carbon. But here, no, the OH, it will be bond to the less substituted carbon. Now, this, if you take this homework, draw the product from which each alkene is treated with the BH3 followed by H2O2 OH minus. That meaning hydroboration oxidation. Okay. I want to write the product from this reaction, from this starting material for this reaction. Okay, that meaning this molecule, it will be react with the hydroboration oxidation. Also this, also this, also this. Okay. Now, طبعا here include the stereochemistry to all stereogenic center. No, this is not important. طلبة, this you can remove this and include the stereochemistry at all stereogenic center. You can remove this. Okay, no, not important for you. Just I want to write the product. What alkene, the second question, what alkene can be used to prepare each alcohol? Okay, as exclusive product of the two-step hydroboration oxidation. Okay, that meaning this product, I want to write the static material. Any static material, by using hydroboration oxidation, give you this product. Okay, also this, any static material give you this product. Any static material give you this product by using hydroboration oxidation. Okay, do you understand? I hope you understand. Just I want to know it is exactly reverse to the Markovnikov rule. Okay. This chapter is finished, طلبة, and the next chapter here.
دكتور بس ميتين كوباري في نوف موديل الدنيا معرف كوباري خوب كاتب باربخيني
جنينة
ميتين كوباري في موديل الدنيا معرف باري خوب كاتب بخيني
مباليه من دانم چاوا
السي ميتين كتير دكتور حطو باري بينجي تشاركي
بس یک دقيقة استأكد كم. Just 1 minute, give me 1 minute. Do you saw this? Yes, chapter 5. I think you. Okay, chapter 5, the alkynes. Look to the general formula: CnH2n minus 2. Okay, minus 2, not the alkane. Alkane plus 2. Alkene, there is no minus or plus 2, just n 2n. Here on the alkyne, carbon n, H2n minus how much minus 2? That meaning how many degree of unsaturated we have here? We have 2 degree of unsaturation. Okay, we have 2 degree of unsaturation here. Okay, and where is on the triple bond? Triple bond, we have 3 bond. That meaning one of them is sigma and 2 pi bond. This is the 2 degree of unsaturation. Okay, now for the alkyne compound, طلبة, alkyne contain carbon-carbon triple bond. Yes, it will be triple bond. And we have we have terminal alkyne, the types of alkyne. We have this, the terminal. That meaning one of the carbon, it will be with hydrogen. That meaning the triple bond, it will be to the end or on the end of the molecule. It will be said terminal alkyne. Okay, terminal alkyne. And we have internal alkyne. That meaning the carbon-carbon triple bond, there is no hydrogen, just alkyl from here, alkyl from here. Okay, at least one carbon bonded to the carbon triple bond. That meaning that triple bond, it will be inside the chain, not on the end of the chain of the molecule, inside the chain of the molecules. Okay, and maybe some molecules big cycle. We have cycloalkynes, but not for the small cycle. I think for the big cycle. Okay. Now, an alkyl has the general molecule, this formula, CnH2 minus 2. Okay, giving it for this molecule for fewer hydrogen. That meaning we have for fewer hydrogen than what? The maximum number of the possible of the hydrogen. For the alkyne, if you compare the alkyne with the alkyne, there is 4 hydrogen different between of them. Okay, and that meaning give you 2 degree of unsaturation. Now, this homework, he said, draw structure for the 3 alkyne having molecular formula. That meaning isomer, طلبة. Okay, I want to, from this molecular formula, give me the 3 isomers. And he said classify each alkyne as terminal or internal. Okay, if you write this terminal, this internal, like that. Okay, a 3 alkyne from this molecular formula. طبعا طلبة, if you have alkyne compound and you want to give the name for this alkyne compound, the nomenclature of the alkyne compound, the same system is the IUPAC system. Okay, is the IUPAC system. And he said in the IUPAC system, change the an, if you have alkane, ending to what? To the ine, Y-N-E, alkyne. And the same thing, the same system, طبعا, no different. Choose the longest carbon chain that contain both the carbon atom triple bond, يعني hard double bond, hard carbon of the triple bond, it will be inside the chain. Okay. Now, compound with two triple bond or more, it will be called as diene. Yes, we know that, or triene. Okay, diene or triene, like this diene. Also this diene. Compound with both double bond and the triple bond are named as enenes. Okay. Hey, where? Anyone? Do we have example here? No, I will give you, I think, on the next slide. Okay, where is like this? Okay, like this. That meaning we have alkene with the alkyne. Enenes. Okay. And he said the chain is membered to give the first side of unsaturation, either the double bond or the triple bond, the lower number. Okay, anyone double bond or the no, yani, there is no difference between the double bond or the triple bond. Okay, anyone, it will be give the lower, it will be take the lower number, put it, check it. You can do it. Okay, no problem. Look to this example. You can also actually read 6, 6, whereas if you have 1, 2, 3, no, 1, 2, 3, it will be like this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, 7, 8. Okay, what we have on the carbon number 6, we have 2 methyl group. Okay, that meaning 6, 6, identical group. Dimethyl octane. Where is the triple bond on the carbon? 1, 2, started from the carbon 3. That meaning 3 octane. Okay, 3 octane. 3 octane. Also this, what we have, 1, 2. Okay, that meaning the triple bond, it will be started from the carbon number 2. Okay, 1, 2, 3, 4. 4. Look, on the carbon number 4, what we have methyl and we have chloro. And then 4, 5, 6. 6, that meaning hex, hexine. Okay, the triple bond, it will be started from the carbon number 2, that meaning 2 hexine. Okay, what we have, the substituent, we have 4 chloro, 4 methyl, this chlor talaba, this Cl here, okay, chlor. That meaning 4 chloro, 4 methyl, 2 hexine. It will be like that, exactly like that. Okay. Number to give the lower number on the first side of the unsaturation. Okay. And look to this. That meaning here it will be 1, 1. Okay, 1, 2, 3, 4, like this. This, it will be 1, 2, 3, 4, like this, not from this side or from that meaning the unsaturation side, the triple bond and the double bond, take the lower number. Okay, like this, also like this. Where's 1, 2, 3, okay, 4, 5, 6, 7, 8. Also octadiene, that meaning the diene where's on the carbon number 1, on the carbon number 5. And we have also here as substituent as the 3 isopropyl. Okay. يعني for this paper طلبة, for this slide, draw the structure, don't look to the names, and you try to give the name for the structure and compare your answer with these names, okay? And you can see it's exactly like these names or there's some different. And be careful طلبة about the comma and the hyphen here, okay? Be careful about the comma and the hyphen. It's so important. And also here we'll explain about the give the IUPAC name for the following alkyne. This the following alkyne. Okay, the longest chain. This is the longest chain, or this. Okay, where is the difference here? 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. The answer he said here. Okay. Now put the number. Okay, any substituent we have here methyl, methyl. That means 6 on the carbon number 6. We have 6, 6 dimethyl, and the triple bond it will be started from the carbon number 3. 1, 2, 3, 3 octane. Okay, 3 octane. And also here, give the IUPAC name for each compound. This structure, I want to write the names, and please compare the names with your friend answers. And if there's something difficult, misunderstanding, write on the notebook. Okay, on the notebook for your homework. Okay, all this. And here, give the structure corresponding to each of the following name. Okay, not you have names here. I want to draw the structure. Now he said the preparation of alkene. Okay, a preparation of the alkene compound. Preparation of the alkene compound. That meaning if you don't have alkene compound, how to prepare this compound. Okay, do you have a question until here, Talaba? Or is something difficult or just general information? No. Look, the alkyne are prepared by elimination reaction. Okay, elimination. What meaning elimination? يعني حذفة. Okay, elimination reaction. Like E1 or E2. What is the difference between E1 or E2? A strong base remove 2 equivalent of the HX from the vicinal or geminal dihalide to yield an alkyne. Okay, we said vicinal, we take it before that. That meaning that 2 halogen atoms on the neighboring carbon. Look, this neighboring carbon, يعني carbon جيران. 1, 2, this neighboring carbon. That meaning both of the hydrogen on the neighboring carbon. For the geminal dihalide or the dichloride, dibromide, that meaning both of the hydrogen atom on the same carbon. Look to the chlor on this carbon, also this chlor on this carbon. This is the geminal dichloride. Above this, vicinal. Okay, not important. Both of them give you the same product. Okay, give you the elimination. Okay, where is the important thing? The important thing, the base, the strong base. That meaning we use strong base here. Remove 2 equivalent of the HX. What meaning 2 equivalent of the HX? يعني remove HX and then HX. 2 molecular of the HX. Look, minus 2 HCl, minus 2 HBr. Okay, minus 2 HCl, minus 2 HBr. By using what? طلب أهم تشت by using strong base. Why strong base? Can anyone give me answer why strong base? Why not weak base? Do you have answer? Can you think about that? Why strong? Look to the structure. If you look to the structure, you will be understand why we use strong here, not weak. Strong base. Why strong base?
الأفضل حتى ياخذ الهيدروجين.
ليش ايش بيها هاي الهيدروجين؟
يعني
çünkü Seyda تبقى لوزة تبقى بيسكي.
لا طبعا base take the hydrogen. This hydrogen يعني take the proton, yes?
حتى أسرع بالتفاعل.
لا ما عم نحكي على اسرع. شوفي take the proton, the hydrogen here. يعني راح ياخذ هذا الهيدروجين. Okay, this hydrogen يعني من ياخذ هذا الهيدروجين يعني هذا الكومباوند acid or base؟
أسيد راح يكون اللي
acid. ليش acid؟ بروتون دونر ينطي بروتون ما تمام بروتون دونر اوكي اسيد انت قلتي اسيد سترونج اور ويك ويك ما تمام
ايه تمام.
ما دام هو ويك لازم يكون عندنا سترونج بيس حتى تشيل البروتون لان هو ويك بيس لان هو ويك اسيد اوكي because is the weak acidity for the starting material we have to use strong base اوكي اذا عندنا هذا البروتون strong acid ما يحتاج بس خلينا نستخدم قاعده بسيطه قاعده weak base it will be enough to remove this proton okay but we use strong base to remove this weak proton weak acidity of this proton okay okay thank you you are good that meaning because this proton you can write here if you have this paper or you can write as a note this proton okay weak acid that meaning we will use strong base okay strong base this strong base to remove two equivalent of the HX from the dihalide starting material okay because he said here because vinyl dihalide are synthesized by addition or adding the halogen to the alkene alkene can be converted to the alkyne by using elimination reaction like this yes okay now look if you have double bond how you can convert the double bond to the triple bond how do you have reaction remove to hydrogen عندنا تفاعل نشيل 2 هيدروجين ما اخذنا هيك تفاعل مو ما اخذنا هيك تفاعل لكن ايش نسوي بالحاله what we do in this time in this case look we will add Br2 addition of the boron ايش اسم التفاعل halogenation that meaning we will add a halogen on the double bond give you what give you Br and then elimination give you triple bond okay يعني if I say to you I want to prepare this compound from this okay how by using two-step reaction the second one addition of the halogen to make it dihalide and then elimination to give you the triple bond okay okay يعني directly طلب one step there is no reaction from the double bond give you triple bond there is no reaction directly convert the double bond to the triple bond there is no one reaction that meaning we have two reaction number 1 addition of the halogen reaction number 2 elimination and give you triple bond okay do you understand okay now convert the alkene A to the alkyne by stepwise method what meaning stepwise method طلبة أو مصطلح مهمة الكيمياء العضوية stepwise meaning more than 2 reaction 2 3 4 not one reaction that meaning if you want to prepare compound from the starting material you need more than one reaction maybe 2 reaction maybe 3 maybe 4 maybe 5 here we called stepwise method stepwise يعني خطوة بشتي خطوة وصل okay he said stepwise method okay يعني وقت بالامتحان طلبة if I say to you prepare for me this compound by using a stepwise method you know what meaning stepwise method okay you know don't say to me سيدة أو شي معنى stepwise method as نظام okay هذا بوتا من شرح كله خلاص okay stepwise wise method meaning more than one step maybe 2 for this example طلبة 2 step this is step number 1 معنى this is step number 1 and this is step number 2 for this reaction okay now step number 1 look addition of the halogen Br2 on the double bond طبعا give you Br second step is the elimination by using strong base that meaning remove minus 2 HBr this H قال أو BR ديتشيفا dependent upon that. This edge قال BR also it will be removed to remake another pi bond. Finally, give you triple bond. Okay, give you triple bond. And this two-step process introduce 1 degree of the unsaturation, and the second also elimination give you another degree of unsaturation, and finally it will be give you triple bond. Okay. Do you understand? تقيشتن حتى في طلبة؟ Okay, I hope that. Okay. Now convert each compound طلبة. Convert each compound to 1 hexane. يعني أو طلبة convert this compound to 1 hexane. How? يعني أو starting material أو product. Convert this compound to 1 hexane. How? By using any reagent, any reaction. Also, convert this compound to 1 hexane. How? Stepwise method. Okay? Stepwise method. Maybe 1 reaction, maybe 2 reaction, maybe 3. This homework for you. Okay? And inshallah, I will stop here. طلبة. Introduction to alkyne reaction. I will stop here to the next lecture, inshallah. And if you have any question, please ask me. If you understand, don't have any question, you can leave the meeting and see you later, inshallah.
Saida.